This is the second video for our test review sheets. We're going to start up with question number 12. Question number 12, what are the x-intercepts of the function? Actually, this is not a function, this is an equation. And that's okay, we'll live with that. What are the x-intercepts of the function y equals x plus 14, x minus 2? Well, class, you should recognize this is intercept form. And if we're dealing with intercept form, then the intercepts are easy to find. The intercepts of intercept form are found. What is the value of x that makes x plus 14 equals 0? And what is the value of x that makes x minus 2 equals 0? The first x has to be negative 14. So our x-intercept is going to be negative 14, 0. And the x that makes x minus 2 equals 0, x must equal 2. So in this case, we have an x-intercept of 2, 0. Next question, number 13. For the function, again, this is not a function notation, this is equation, but that's okay. And the 14 is the same way, just ignore those, class. For the function y equals x plus 14, x minus 2, the x value of the vertex is negative 6. What is the y value of the vertex? Now, I had a lot of you asking me this question yesterday in class. And you have to remember, this is not a complicated question. This has to do with, do you understand what a function or what an equation here actually does? And in this case, this is a machine, class. We've talked about that. You plug in x values and out come y values. When you plot all of those on the graph, if it's a quadratic equation, which this is, you get a parabola. A parabola is just every possible x and y value that make this equation true. So when you are told what the x value of the vertex is, all you have to do is plug it into the machine and out will come the y value of the vertex. So all we're doing here is just taking the x's and replacing them with the x value of the vertex. This is going to be negative 6 plus 14 times negative 6 minus 2. So negative 6 plus 14 is actually positive 8. And we are multiplying that. These binomials are being multiplied together. So 8 is being multiplied by negative 6 minus 2, which is negative 8. And if you multiply that out in your calculator, you will get negative 64. So the y value of the vertex is negative 64. Let's take a look at this again. Same one, number 14. For the function y equals x plus 5 times x minus 7, the x value of the vertex is 1. What is the y value of the vertex? I forgot to note up here, class, even though it doesn't matter. This is intercept form, but in this case, no matter what form it was, if they gave you the x value of the vertex, you just plug it in to get the y value. Same thing here. We're going to plug in our x value of 1. So our equation is going to be 1. Now if you know what, up here, you could put y equals as well. So y equals, if I'm going to do it mathematically correct, this is going to be y equals 1 plus 5 times 1 minus 7. So y is going to be equal to 6 times 1 minus 7 is negative 6. And so y must equal negative 36. So that's how you find the y value if you are given the x value. Question number 15. For the function y equals negative x squared plus 2x plus 7, what is the axis of symmetry? Well, let's recall something. I'll write this over here, class. If you have a coordinate grid and I draw a parabola, the axis of symmetry is going to go through the vertex. Through the vertex. And it passes through the vertex at this x value right here. So this x value defines the axis of symmetry. That means the axis of symmetry comes from the x value of the vertex. And the x value of the vertex of a standard form quadratic, this is standard form, You look in your flip book, it is found with the equation negative b over 2a. Our b value here is positive 2. So we're going to flip the sign of that. It's going to become negative 2 over 2 times our a value, which here is negative 1. In fact, I just skipped a step, class. Very important. You just go through this process. Standard form, a is negative 1, b is 2, and c is 7. So now we get the right numbers plugged in here. And negative 2 over 2 times negative 1, which is negative 2. Negative 2 over negative 2 is positive 1. Now you can't just write 1 as the axis of symmetry. It's an equation. It's where x equals 1, which defines this whole line right here. So that's how to find the axis of symmetry for a standard form quadratic. For the function y equals 2x squared plus 8x minus 3, what is the axis of symmetry? So for number 16, same process. We figured out this is a standard form quadratic. Let's identify a, which is 2, b, which is 8, c, which is negative 3. We find the axis of symmetry with negative b over 2a. Since b is positive 8, it turns negative in the equation times 2 times a, which is 2 times 2. We've got negative 8 over 4. In class, don't flip this around. Some of you will write this as negative 1/2. If you want to put this in your calculator, you put it in like this. The negative sign 8 divided by 4. And that's going to give you a number negative 2. That means our axis of symmetry is at x equals negative 2. I'm going to end this video because we're going to be flipping the page over. We'll start up in the next video on the back side of this worksheet.